Done. Redirecting to the live streaming page.
I closed it and put my phone on airplane mode.
Cool.
Put the ball in my head.
So it says 3 waiting. What do I do about that? It's ready, right? All right, so now I'm going to go to the Zoom.
It says that it's live now.
Are we live?
Well, I'm seeing this live button on custom live streaming service.
I'm also seeing live. Are we in fact live? The question of the hour.
Doesn't look like it if I click on the video.
Let's see. It does take a minute.
Are we going to be delayed?
Okay. It shouldn't be. Ah! We're both able to type in the chat. What the dork? How does this work?
You probably should have done a practice run first. Oh,
Yeah.
well.
Thought I had this figured out. I'm sorry. Why isn't this working?
The alternative, assuming we can't get it working in the next 5 minutes, is that you could just go straight now, just type aggressively, chat aggressively at you in.
What if we do this? What if we try to use... What if we use... Do you have a Restream account?
No.
Oh, I don't know if it's gonna freaking work. What happens if I enter Live Studio? This is not gonna work the way that I want it to. It thinks we're live. Why aren't we live?
What happens if I log out and see what happens?
Okay, try
you
that.
get yourself live without me, and then I can try joining.
Okay.
It's a backup plan. Leave.
Okay. Are we live? Hello. Waiting. Report. We might have it figured out now. What is happening? What is happening? What is happening? Did that fix it? Did that fix it? Awesome. Did that fix it? Oh, is it back? All right, it should be gone now. Oh my gosh. Okay. No. How about now? Are you here?
Can you hear me?
Oh! I can hear you.
I am pausing the live stream so I do not get it coming from both speakers. Sup?
Hey, how are you?
I'm doing all right.
Good. Yeah, I ended
Things are
up
better than they
also
were
having
about
to
20
pop out
seconds
the
ago.
chat and then close the stream.
Okay. Yo. Hi, everyone.
Hi, everybody. How's the sound now? Is it better?
Can everybody hear me?
I know that we had some cricket tomfoolery there for a while. It's better. Ah, all right. Welcome.
Yo.
So, hello, what's on your head?
Hair?
Nah, no, that's not true.
COVID. You don't know what hair looks like anymore. Nobody's seen anybody.
uh, it's so true and so sad. What can you do? That's why we get to do lovely things like video chat for everything.
Yep.
But I've found that I'm live streaming more now that everything's on video anyway. I don't know if that's a good thing or a bad thing.
It's probably just a thing, like depends on how things work out.
Yeah,
Thing.
fair.
So what are we here for today?
Yeah, today we're going to look at alloy. So here's the whole story. Essentially, I work on some kind of a software engineer by trade. My name is Chelsea Troy. I write code for money. And one of the projects that I work on is this data processing pipeline for NASA LandSat data. There are these satellites that circle the globe. They take pictures of, well, they don't really take pictures. They collect information about the different wavelengths of radiation that are reflected back at the satellites, and then we can use that to create images of the Earth's surface. So I work on a system that does that. And recently I took Hillel's alloy workshop to learn all about model checking. Is that the correct term? Structural
It's close enough. I think getting into like a lot of like just getting into like a lot of tangents about what like the proper terms are is kind of going to be a waste of everyone's time. So yeah, model checking.
Okie dokie. Um, cool. And so I decided that what I wanted to do was try to model the system that I work on myself to figure out how, first of all, how to kind of use alloy because that's the thing that I'm the least familiar with in the system at this point. And so I came up with something. And there is a live stream where I walk you through that's recorded that I'll link in the description to this once this is done and recorded and everything. But we'll do a little walkthrough at the beginning of this as well. So basically, my familiarity is with the data model, but then I'm not as familiar with Alloy. And so, of course, Hillel sits on the Alloy board, teaches about Alloy. Would you call yourself an Alloy expert? I would call you an Alloy expert.
Yeah, probably.
Okay. So it seemed like a good idea to get the perspective of somebody who actually knows what they're doing on what has happened here and how to make it better.
Well, yeah, and I'm happy to help. We'll see where we can take things.
All right, very cool. So let me start with this. Let me see if I can share my screen. We're in uncharted territory again with the screen sharing.
It's gonna try.
But
It's gonna share my screen somehow.
it's just gonna we're gonna somehow end up with goat to meeting where they give you a goat. All right, here we go. So I'm gonna share.
Okay.
All right. Can you
I can
see?
see it in the Zoom, and yeah, it just popped up in the YouTube.
Zoom and YouTube. All right, folks can see. So this might be the appropriate place to start. Let me zoom in on this image. I tried to draw a picture. I think well through pictures, so hopefully this will be helpful, but we'll also go through an actual list of the requirements for folks for whom that's easier. So here's basically the way the system works, is that we get these data files down from a service that gives us this data that it collects from the LandSat satellites. And we get that data in a file format called TIFF, T-I-F. Then the software that I'm working on is designed to allow researchers to put together any series of steps that they want to transform that data into a finished product that they can use for whatever their research purposes are. For the vast majority of these researchers, that's going to be creating some kind of image representation of this data so that they can then visually compare the different images and look for things in the images. So an example of this would be the Floating Forests project, which I can also link in the description, but they're using this system they get down data from the LandSat satellites. They look for infrared radiation in the data. We create a pictorial version of that data that shows where the infrared radiation is coming from, which helps them identify where there's going to be kelp on the coastlines of the world. And the project catalogs where the kelp is and how the kelp is growing and how the patterns and how it's growing are changing over time. And they've discovered some pretty interesting correlations between that and potential effects of climate change and that kind of thing. So that's an example of how this pipeline might be used. Does it support Markdown?
No, it doesn't. I was
Okay.
testing to see because if it would make sense if like we were talking about how to improve stuff, whether it makes sense to send the snippets publicly by chat or if I'd have to sort of try to verbally walk you through it.
Yeah, that's a good question. Well, we can try. We'll see how this works. I'm sure we'll come up with solutions. We're smart. We'll figure it out. Yeah, so this pipeline, the thing about it is that the researchers should be able to put any number of steps in it, and they should be able to put those steps in a semi-arbitrary order. And I'm saying semi-arbitrary because there are a couple of different things that entails. But what you see is the data model here. And so in the big rectangle, you have an account that represents a research team, such as the Floating Forest research team. You see at the bottom researchers, so multiple researchers can access an account. An account has pipelines in it, and for now we're going to say any of the researchers can access any of the pipelines. We'll keep it simple. There are 3 pipelines in this account. I've only illustrated one. A pipeline has multiple stages, and this is where a lot of my time got sunk while I was making the first version of the structural verification thing in Alloy, is that a pipeline can have many stages, but it needs to have one beginning stage and one end stage, and it needs to be like a line. One stage points to the next, points to the next, points to the next, all the way to the end. No trees, no like converging types of situations. And also, the output format of every stage needs to match the input format of the previous stage. That's what the little puzzle pieces that you see in the stage diagram are indicating. Because if we get down TIFF data, the next stage needs to be something that can take in TIFF data. And maybe if that outputs a JPEG, then the next stage needs to be something that can take a JPEG as an input. Because if it can't take whatever the data format is, then the pipeline's going to break. So I tried to write that out here. This is basically a representation of what I've just kind of explained, that an account, it has pipelines and it has researchers. So it can have, the way that I modeled it, I believe it can have 0 or more of any of these things, but it can have any number of them. A pipeline then has any number of stages. All of an account's researchers have access to all of its pipelines. For now, a stage can only belong to one pipeline. You can't share stages between different pipelines. A stage has 0 or 1 next stages. It has 0 next stages if it's the final stage. A stage also has exactly 1 input format and exactly 1 output format. Ultimately, maybe this would change, but for now, that's the way it's going to be. And then a stage's output format has to match the next stage's input format if the next stage has an input format. And then there are also some requirements on the format that the first stage and last stage need to input and output. So the very first stage has to take TIFF as an input because that's what we get down from the LandSat service. And if it's the very last stage, the output format has to be JPEG because that's what we use on the people-powered science platform that we're uploading all this data to. Does that kind of make sense?
It does to me. If the audience would like to sort of say if it makes sense in the chat, that would be great.
What do folks think?
So I have this nasty habit in workshops I do where I say, instead of saying, does anybody have any questions? I say, we will not make any progress until somebody asks a single question. I'm not going to do that here because none of you signed up for that, but it's a very good teaching technique because it forces people to actually think about really hard to figure out what would be a good question to ask.
I like that technique. So that was the first time I had seen that technique used. Actually, was in your workshop, and I read about something somewhat similar. So there's this book by Kathy Davidson. It's called The New Education, and it's my latest. It's my second to latest read about education. So I teach at the University of Chicago, and I'm always on some tangent trying to figure out how to get better at it. But so in this book, she talks about one technique where the teacher makes everyone raise their hands, and then for every question, everyone has to raise their hands, and then the teacher calls on somebody at random. So it's a little bit different, but it reminds me of your technique insofar as that somebody's asking a question before we move on.
Right.
But all right, people seem satisfied. So that's going to change pretty soon because I'm about to show you my code. Don't worry. This is what I have so far. And for those of you who are familiar with Alloy, the first thing you're going to notice is my preponderance of facts, but I promise we're going to get there.
So does everybody here know what Alloy is, first of all?
Got anybody new to Alloy? You could speak up. It's okay. That's what we're here for. Should we do the high level?
Yeah, let's just go with the high level. Essentially, Alloy is a modeling language. It is a language you can use to write designs of systems, especially systems that involve a lot of relationships like pipelines or ETLs or authentication protocols. And what it does is it lets you sort of give these things, and it either gives you examples of systems that match all of your requirements, or it gives you systems that break your requirements, depending on how you set it up. So you get to choose how you use it. And it is very good for these kinds of problems, like pipelines, as we're going to use it.
Yeah. So, yeah, it's an exciting thing for me to take a look at on this pipeline because this is something that I'm already in the process of implementing. And this is a system that it's going to be important for multiple people to be able to understand and to be able to maintain. The reason for that being that the plan is for it to be the most straightforward way to use a corpus of data that a lot of researchers, especially earth science researchers, are really interested in using right now. And ultimately, like it would be ideal if folks could make changes that allow them to put their pipelines on to the system, which means that the system has to be straightforward enough that somebody without the background in it that I have is going to be able to get in and figure out how it works. And one of the things that I have learned over my career and of recent especially about code is that the understandability of the code has a lot to do with the way it's implemented, but you can also heavily influence that in your initial design of the data model. So there's a distributed consensus algorithm called RAFT that I was implementing a while back over the course of a few months. And every time I would stop to refactor, one of the things that I was realizing was that the way that that system is designed, there's like relatively little ambiguity relative to the complexity of what it's doing. There's not that much ambiguity about where you would probably want to put things. And I thought that that was really cool because it made it easier for me to design something at the beginning that design kind of ended holding up towards the end. And that's what I'd really like for this project. So it seemed like it would make sense to do some structural verification on it in the beginning, figure out what edge cases am I going to run into. Hello, you can let me know if I'm not right about this, but one of the things that I'm seeing as an implementer as I use Alloy is that a lot of the conditions that we end up programming in Alloy, they surface in the implementation as conditionals. And as much as I can avoid like various conditional logic and edge cases, the more simple my implementation is going to be. Does that sound accurate?
Everything is edge cases. Society is edge cases. Edge cases are, is this a swearing stream?
Go ahead.
Edge cases are heck.
That's fair. Yeah. So, yeah. Do you think we should go ahead and get into the signatures now?
Yeah, let's start with describing what we currently have, and then we can start going into what we can do to make it better.
Awesome. All right. So this is what I have right now. If I think that this would hopefully be big enough, but actually let me go ahead and make it a little bit bigger for people to see. So I'm going to go into theme, and I'm going to make the font size 20, and then we'll apply it. Oh, that doesn't apply to the code, does it? Or it does?
Oh, for the code, you have to go to options in the top bar.
Options.
Yeah. And there should be, font size over there. There we go.
I almost know how to use this editor. So Raul asks, so then the Alloy output would be a guide for the transform implementations.
It could be. It will give you visualizations of what examples could look like. So people could use that to sort of add more rules to refine existing examples they have, or they can use it to sort of shape how they're going to design the overall system. It's the output is agnostic in how you're supposed to use it. You can, if you can find a way to adapt to your problem, you can.
Rock on. We're going to see some visualizations too, so you'll get a good idea of what we're talking about. So the first thing that I'm going to go over are these 5 signatures up here. So a signature, if you're a programmer, then you might be familiar from imperative programming with classes. So signatures are somewhat comparable to classes. And in Alloy diagrams, they are going to be represented by shapes. And you'll see what I mean by that in a second. But for now, we're using a signature to represent each of the models that I have right now in my data model diagram of the system. So the first one is an account. And the account represents this big rectangle up here that contains all the pipelines that all the researchers have access to. Then I also have researcher. And researcher has a field on it. It can have some number of accounts. That's what this means. So it has a field called accounts that is associated with one or more accounts. That's what sum means, one or more. Then, ooh, this thing scrolls kind of fast. So that's researcher. So you can imagine what pipeline is doing here. We have a pipeline. That is this smaller rectangle with all the stages in it. And a pipeline has an account. It has just one account. So a pipeline lives in an account. And then we also have this signature stage. It has the abstract modifier in front of it. We'll come back to that. But for now, we have the stage signature, and it's got a few fields on it. The first one is the pipeline, because a stage belongs to a pipeline. The second one is an input format, because a stage has exactly one input format. And then it has an output format, because a stage has exactly one output format. So then we also have the format signature right here, and several different types of format: TIFF, JPEG, PNG, JSON, and CSV, for this example, are the types of format. So you'll notice that each of these fields refers to one of the other signatures. In Alloy, we use these fields. These fields don't work the same way that attributes do on classes necessarily. The fields are there to help us delineate the relationships between the different signatures. Hello, would you say that's accurate?
That's accurate. Basically, the signatures are the types, and then the fields represent relations between types.
Awesome. So yeah, we have these 5 different fields that all relate to each other in various ways. So
I'd like to point out one quick thing for the audience. SIG, TEF, JPEG, PNG, JSON, CSV with the abstract format. That's a pattern in Alloy, a pattern that gives you enums, essentially. So now we have an enum that, like, let's just say that there are these 5 things that all represent formats. I would suggest you put a 1 SIG before that, so that way it doesn't create 5 JPEGs or like 23 PNGs. There we go. Yeah.
Yeah, that's a good idea. Because I'll tell you in the diagram, and you'll see this if I take that off. That was one of my questions for you,
Yeah.
because we end up with these like situations where several of them will point to like one TIFF, and then several of them will point to a different TIFF, and I'm like, that doesn't make any sense. Let me put the 1. Rock on. This particular diagram is pretty funny for a reason that I'll describe in a second. But so this is a diagram. We'll go through the rest of this, but I'm going to skip to the bottom to show you that I'm doing this run at the bottom, which gets me 20 nodes and exactly 3 intermediary stages. We'll talk about what that means in a second, but when I run it, then with this execute button with the lightning bolt at the top, over here on the right, I get this text and then instance found. The instance is in blue. And when I click on instance, I get this diagram right here. So this diagram is saying, according to all of your rules, this should be a valid version of your data model. So we have one pipeline with one account. That's good. And then we have our
Spaghetti.
stages. What'd you say?
Our spaghetti.
We do have our spaghetti. This, I don't know if there's a way I should be organizing it that is better than this.
I think once you make some changes to like the model, it'll be easier, but also there's like some ways of theming it that would help a lot.
Okay, awesome. I think I already managed to theme it to be like upside down, kind of. So accounts appear at the top and not the bottom, but
honestly, I'd make TIFF, JSON, and I'd make all of the actually, here's one thing let's do right now. Go to theme.
Theme.
Yeah. And go to format. It's here. Under SIG unit. Yeah. Click. Actually, no, that's already inherited. We don't have to worry about that part. So the other thing that we want to do is go to input format.
Input format.
It is under relations. It is the 3rd relation you have under the relations, which is the next paragraph. Yeah. Change that from show as arcs, turn that off, and show as attribute, turn that on.
Like that.
And turn off show off arcs. There we go. And now hit apply.
Apply.
Whoa. So now you see it gives us the input formats and the as like just fields.
Oh, look at that.
And notice how it also got rid of the JSON. Actually, no, it still has JSON. Actually, if you change output format to also be an attribute, it'll get rid of both the JSON and the TIFF.
Oh, I like that.
It will be unconnected.
That. Yeah. And then when I apply that, yeah, this
there we go.
Great.
And finally, if you want, you see how you can next to above show as arcs, there's that output format text string.
Yes.
If you want, you can just rewrite that as out.
8.
Yeah, and then now if you hit apply.
Apply. Oh, how about that? And then I could do the same thing for input format.
Yep.
In, out, apply.
Yeah.
How about that? Well, that is definitely easier to see.
Mm-hmm.
And then we can just make sure that it matches when we look at it.
Yeah. I mean, I'd actually even project over pipeline too. If you go to a projection and click that none,
Project over pipeline.
Yeah, so you see how next to magic layout, there's a button called none?
Yes.
Yeah, if you click that, and then you click on pipeline. There we go.
What did that do?
So basically what it does is it now essentially you only have, if you have multiple pipelines, it'll chunk up the pipelines into separate buttons. You can see that actually on the bottom below the layouter, below
Oh,
the
yeah.
visualization, there's that pipeline thing. So what happens is you can basically go between the different pipelines you have, and it'll basically just show the flattened representation of that one pipeline.
Oh, that's great. And we only have one in here, which is why
Yeah,
these.
so it's a nice thing to clean up. And then finally, I'd probably just tell format to hide them if they're not connected to anything. And that would just make the JSON and the TIFF disappear as signatures. That's basically everything.
How would I hide them?
If you go to SIG format,
SIG format.
under types and sets is the second under past. Okay. And then you see how you have hide unconnected nodes?
Hide.
Turn that on. And now if you hit apply,
apply, and they go
this
away.
says that if there's no arrows pointing at that node, it will just hide it.
Gotcha.
Yeah.
Sweet. So this is already a lot easier to see.
Yeah.
Fantastic. All right, so we got our stages here. So we've got one initial stage. The idea is the beginning one has to be an initial stage.
Mm-hmm.
The end one has to be a final stage. And then each one has a next stage that connects it to the next one. So we have our next stage, this intermediary stage. All the middle ones are intermediary stages.
We can change how those look layout if you want, but I think we've already done enough theming in case people are getting bored of seeing themings.
Yeah, maybe we come back to it.
Yeah, we can come back to that. But I already see an issue with this pipeline.
Yeah.
You said that the initial stage has to be a TIFF, right?
The initial stage does have to be a TIFF.
But the input is a JSON.
Oh, this might actually be my mistake. I might have said JSON in the... This might be my mistake, because I think that the input for initial stage does actually have to be JSON, and then its output is TIFF, because the initial stage always does the conversion from the API response to the TIFF.
Okay.
That might be my mistake, but let me...
Okay, but notice, look, let's also go to the outputs, the final stage.
Yeah, okay.
The output stage, is that supposed to be a JPEG or a JSON?
I think it's also supposed to be JSON, but the input stage for that one is supposed to be JPEG.
Okay.
So I think I messed up when I wrote the original thing, but the way that the initial and final stages actually are supposed to work, which is not what was represented in that diagram that I showed you, is that the first stage is always a stage that it always does the same thing. And what it does is it gets the data down from the service, and the output needs to be those TIFF files, and then whatever the intermediary stage is needs to take in TIFF files.
Okay. Okay. That makes sense.
And then the final stage needs to take, it doesn't matter what the input to the final stage is, but the output does have to be JSON.
Okay.
That makes sense. But I think that is not properly represented in the original specification.
Yeah. Let's show the audience really quickly that once we close this out, we can actually go show more diagrams.
Okie dokie.
So if we click the close on the layout, click close on the layout. Not on the yeah, reopen the instance. And now click next to project over pipeline. And now this gives us a different layout.
Ta-da.
Wow. And this one even has a researcher in it.
This one has a research. There's somebody involved.
What happens if we click next again? So if we keep clicking next, eventually what we'll see is that there'll actually be multiple there will be multiple possible pipelines, and then it'll let us project and sort of look at those individually.
Right.
This one seems to have a lot of accounts and researchers.
Cluster fumble of accounts and researchers. Wow, this is amazing. Look at this. Look at all these researchers collaborating with each other. This would never happen.
Have pipelines.
They're all collaborating and doing no work. Wow.
We call that academia.
Whose is this? Whose does this belong to?
It belongs to account 11.
This one.
Yes, which nobody is connected to.
Nobody is connected to this one. Amazing. Well, maybe we should fix that. Probably there needs to be at least one researcher on any given account with a pipeline in it.
Depends.
This is pretty awesome.
Okay, so oh, see, this is interesting now because yeah, so what you can see here is this actually involves multiple different pipelines.
Hmm.
And it's showing them separately, but it's saying that some of them have that pipeline like note on them. Can I actually put on like, can I actually turn on a cool, uh, I was going to see if there was like a way that I could annotate, which would be cool, but just notice how there's actually now two initial stages and one is marked as the pipeline. So now we can actually click the left and right arrows below the pipeline 0, and then it'll basically switch to which pipeline we're looking at. I like the one that has initial stage and a final stage. It just takes in the JSON, spits it to a TIFF, and then spits it back out to a JSON.
Yeah, this is just, yeah, this is like somebody knew how to use this tool and didn't know how to use tools that are for whatever's happening here. And so they just did this.
It's their hello world.
This pipeline is where somebody brought a fire hose to a water gun fight and made this rather than like a connection between these two. Amazing. All right. Yeah, so we got one with one intermediary stage here. So there can be an arbitrary number of intermediary stages. That's 0 or more. So we have 1 here, we got 0 here, we've got however many we got here, 2.
Because we said exactly 3 intermediate stages in the model.
Which means it has to be 3 overall in the whole example. So then what would happen if I, whoa, where am I? What would happen if I took this away? I think the reason I had this on here was because the SAT solver, when I did this, was spitting out a bunch of models that were not.
Yeah, you have to, this is like where the things of like actually are finding things. Let's go into like let's go back into sort of all this facts we have and what they're supposed to do.
Okie dokie. So let's talk about facts. So we have a question. Are pipelines with 0 intermediary stages useful?
Depends on the client.
Yeah, it does depend. So that's a good question. Do we want to allow them? I will say that they would not make a lot of sense because the purpose of the pipeline is to get down these images from LandSat and do something to them that makes them visible. So when they come down, they're essentially a whole bunch of numerical data illustrating where the different like which radiation was the strongest where. And those can then be rendered into images essentially so that you can visualize what's happening in the data. It doesn't come down as a visualization though. And so if you were to, the first stage of this pipeline always converts the JSON to TIFF, and then the last stage always puts it up on a platform where researchers and also people like you and me can look at the images of the Earth's surface. So if they weren't in some kind of image format by the final stage, that would be weird. It would definitely be weird to use this system without intermediary stages. It did transformations on this data. So that's a good question. Maybe we should look at that going in. But let's take a look at the facts that we do have. And we'll also get into these extensions of our stage, because in fact, one of the things that you'll have noticed about our diagram is that we introduced stage as a signature, but we don't ever have stage in the diagram. It's always initial stage, intermediary stage, or final stage. Okay. So we have these 3 types of stage. So we have final stage right here, which extends stage. You recall that this pattern allows us to essentially create an enum in Alloy. Now, we do it again with passing stage, but this one's a little bit different because with passing stage, we add a field that the super signature stage doesn't have. So here we're adding a field called next stage because the final stage doesn't have a next stage, but all of the other stages do. So initial stage and intermediary stage both extend passing stage, so they both have the next stage field. Oh, well, what did I do? They both have the next stage field.
Notice there's also a line below it. There's a extra typo that was added. There we
Aha.
go. Yeah.
Fixed, I think. Is this the way that you would do this? With like a hierarchy of abstract signatures?
Personally, I probably would do things slightly differently, but we'll get into that later
Okie
when we're
dokie.
talking about best practices.
Okay, sounds good. So we have our initial stage, our intermediary stage, and our final stage. So now we get into some of these facts. And what we're doing with the facts is that anytime we have a fact, that's something that's always going to be true in examples that we are shown of the model. So if there's a fact that says that something can't happen, then Alloy is not going to show us examples of the system in which that thing happens. Is that correct? I think so.
That is correct. Basically, a fact is something that cannot be true. Sorry, is a fact that something that must be true. And when I say must be true, I mean that if it was always false, we've got bigger problems. So, like, for example, it might be a fact that there's 7 days in a week, because if that ever becomes false, then, oh God, I think somebody just changed the entire calendar and now I've got to reprogram everything.
Mm. That makes sense.
Yeah.
So that would be a bigger violation of the boundaries of reality, perhaps, in a lot of the facts that I have written here, which
Yeah,
maybe
that's an
is
extreme
a sign that I
case.
shouldn't have so many facts. But
Yeah. And I'll talk about why facts tend to be an anti-pattern. It's not like bad to use them, but like you get advantages from not using them. Yeah, Frank, it would be fair to describe facts as axioms of the system,
cool.
but complicated axioms that you're not interested in sort of building the system to enforce. They already come pre-enforced for you.
Sweet. All right. So the first fact says that the next stage is always in the same pipeline. So this fact I put in to ensure that we don't have stages attempting to cross pipelines. So we don't have a stage whose next stage is in a different pipeline than the one that it is in. All of the stages that are connected together should be in the same pipeline. And so what I've done here is I've said that for every intermediary stage or initial stage, all of the next stages, so that stage's next stage should be in the same pipeline. And not only that, but this transitive closure here indicates that this stage's next stage should be in the same pipeline, as should its next stage, and its next stage, and its next stage, so on and so forth to the end. So
Right.
this is going to make sure that all of our stages are in the same pipeline. I think. I hope.
Yeah. It should, yes.
Rock on. All right. And so we've taken care of stages trying to cross pipelines. The next thing to think about is the pipeline having one beginning and one end. So we want it to have just one initial stage and just one final stage. And that's what we're doing here. So now I'm saying that for every pipeline in a system, the set of all the stages that belong to that pipeline and the set of all the stages that are final stages, those two, we put those two sets together, and whatever satisfies both of the requirements, there should only be one of. So there should only be one final stage for any given pipeline. Is that an accurate description, you think?
Yes, that's an accurate description of that fact.
Rock on. And then the same thing for initial stage. So one thing I think I was running into was that I thought this and should happen automatically, but then I was running into some kind of error when I didn't put it in.
Yeah, that's the pipe only does one. You have to use braces if you want to. If you want to have the implicit and, you have to use braces instead of a pipe.
Oh, like this.
Yes.
I see. So this would work.
Yeah.
Which one would you do? Would you do the and or would you do the braces?
It depends. I use the and when it's going to be nice and short, and I use the braces when it's going to be like multiple different things. And here we can actually make this a lot simpler. So I'd probably use the pipe, but generally use whichever one feels more natural to you. Whether you use, let me put it this way, whether you use a pipe or braces is a style issue that is not the important is not sort of the important like techniques to build up.
Gotcha. All right, that's good to know.
Yeah.
We're going to come back to this, so I'll leave it like that for now with the
Yeah.
parentheses. All right. So then, okay, so that's great. The next thing that I ran into, and so I'll tell you how I developed this. Essentially, what I would do was I had my signatures, and what I would do is I would run the model and I would look at the instances and I would identify examples where stuff was happening that shouldn't happen, and then I would come back and I would write facts to attempt to prevent that thing from happening again. And so, for example, with the one beginning and one end, what I was seeing was it would make me a pipeline that had two different initial stages that both pointed to an intermediary stage. And it was all in the same pipeline, and it satisfied all the rules, except that I hadn't delineated anything about how there should be one initial stage that goes through some intermediary stages and then has a final stage. So that's how I kind of developed this. Probably more rigorous way to do it would have been with checking various things along the way, but we'll get to that.
Mm-hmm.
Okay, so then we have no stage cycles. This was another one where I ran the instance and I found that I had like I had a stage that was pointing to a stage that was pointing back at the first stage, or a cycle of 3 at one point. Mm-hmm. So that's what this fixes. And essentially it says that for any given stage, a stage is not going to be in its own descendants tree. So each stage is not going to be its own next stage, and its next stage is not going to have it as a next stage, and so on and so forth. All right. And then, so no converging pipelines. So this ensures that we do not have pipelines where like multiple different stages point to the same stage. Now this one's a little bit interesting and introduces some syntax that we haven't seen yet. So for all intermediary stages and final stages, that's what that plus means. It puts those two sets together. For all intermediary stages and final stages, so anybody who can have a next stage pointing at them, for all of those, there should only be one stage whose next stage is them. And that's what that tilde means. It essentially reverses the relationship. So s.nextStage points to a stage's next stage, and s.tilde next stage points to any stage whose next stage is the stage that we're looking at.
It points to the previous stage, basically.
There you go. Previous stage.
Is potentially, and then this fact rules out that there can be, that says that there is one previous stage and not many.
Right. Exactly. Mm-hmm. Yeah. So, all right. So in this one, initial stages don't have precursors. I tried to name these fairly clearly. I don't know how successful I was. Okay, so the initial stages, they don't have precursors. What this means is that any initial stage should not have anyone pointing to it as its next stage. It has no previous stages, in other words. Mm-hmm. That's what this is. We'll come back to that.
That's a function.
That's a function.
It's a function. You all know what functions are. So, you're programmers.
The functions in Alloy we're using chiefly for legibility. And so somewhere up here we used stages, which seems like p.stages right here. So if I didn't have that function, the way I would have to write this is like this. P tilde pipeline. Meaning any stage that identifies this pipeline as its pipeline. But that, like, it's not intuitive that this is referring to a bunch of stages. So we made a function called stages that does it for us. And that's what that does. Ta-da! All right. One thing perhaps to note is that Alloy does use these square braces, where most programming languages that we're used to would probably use rounds. I don't know what you would call parentheses. That's what those are called. Rounds.
They're crowns now. They're now frowns forever. I honestly think of braces as fangs is like the usual term I think of them internally, like left fangs and right fangs.
Really?
Because if you make the smiley with braces, like a frowny face, it looks like a vampire that has fangs.
Oh, that's true. I always think of them as mustaches.
Oh, those. I'm thinking of the. I'm thinking of brackets. Brackets I think of as fangs.
Brackets are fangs?
Yeah. And then braces are just braces.
Braces. These are always mustaches to me. And then I'll call these square I think usually I know the word parenthesis. I don't know what's wrong today specifically, but all right. Okay. So, cool. All right. So now we got some more facts. Uh, this one says one stage list per pipeline. So the idea here is that no pipeline is going to have multiple like sets of stages in it. Each one has only got one. And so for each pipeline, we are going to have either 0 stage lists or 1 stage list. And the way that I've done this, I don't like this one. I hope there's a better way to do this. But essentially, um, all of the stages in this pipeline,
Mm-hmm.
and so of all the stages in this pipeline, there should be fewer than 2 initial stages, meaning 1 or 0.
Mm-hmm.
So this probably should have been done with loan or something, but this is how I did it.
Right.
Reason being, I mean, ideally you wouldn't have a pipeline with no stages in it whatsoever, but what I'm imagining is that when a researcher creates a pipeline, it doesn't have stages in it yet. So that's why that needs to be allowed.
Yep.
Cool. All right. So then we get into the formats. This part I didn't have as much trouble with as I did the rest of the stuff. I don't know if that's good or bad, but so I wanted to make sure the initial stage had all the right formats, so I set its input format and its output format, which are different than what I said on the paper, but this is actually what it's supposed to be. And then the final stages have all the right formats, so the final stage can take in any input, but it's got to have an output of JSON. And then this is the fact where I make sure all the stages have matching formats, so for every initial and intermediary stage, those are all the stages that have next stages. The output format has to match the next stage's input format.
Right.
And then I made this predicate that I'm not using, apparently.
Right. A predicate is basically a Boolean function.
Cool.
So the reason we say that facts are an anti-pattern is because facts are always true, right?
Mm-hmm.
And often for programs, you want to be able to turn them on and off.
Mm-hmm.
So that doesn't really play that much relevance here, because it turns out that a lot of your facts, and this is why I talked about the idea that like pipes versus braces isn't as important as like more fundamental stuff, because there's 2 things I've noticed in this discussion that I think would simplify things dramatically. One that's small that I'm going to recommend to you just out of good like hygiene, and then one that will potentially allow you to eliminate almost all of your facts.
That would be great.
Like
I'd
one
love
fact.
to eliminate facts.
Right. So first of all, I noticed that you have a lot of cases where you're like the size of the set equals 1 or the size of the set is less than 2.
Right.
You can just write 1. Like instead of saying like, because let's swap one where you have like equals 1.
Okay. Like these.
Yeah, you could just say 1 p dot stages in final stage.
Does it have to be in? Does it have to be in parentheses?
Nah,
It doesn't even need this?
no. Because
Wow.
1 is a Boolean statement, and the only way to get a Boolean out of that is to, sorry, it's a quantifier. And I think the quantifiers have lowest precedence.
Oh.
Yeah.
So this is what I want here.
Yeah.
So I also want that here. 1.
Right. But let's not get too hasty on changing these. And of course, from the fact below, we could just say no. No s dot next stage.
No.
Scroll down scroll down to the fact below it.
Oh, here.
Yeah.
So this is going to be no, which means 0.
Yeah. But now notice something interesting. We have for every initial stage, there is no next stage, right?
Yeah.
Now, one of the interesting things about Alloy is that you don't just have to do relations on individual atoms, as we call them. You can do relations on sets, right? So initial stage dot till the next stage is the set of all possible stages that have as their next stage an initial stage, right?
Ah. So it can be no initial stage. And we don't need this.
Yeah. There we go. Much simpler.
Wow.
Yeah.
That is better.
But you have a lot, but that's sort of immaterial to sort of the main thing I think matters here. Fundamentally, a lot of your facts are sort of dancing around the one core property you want, which I'm going to say is the following. Notice how final stage cannot have any, does not point to anything, right?
Mm-hmm.
That means that The only ways for your system to be valid is either for it to have a cycle where an intermediate stage points to another intermediate stage, or for it to include a final stage, right?
Yeah.
So the fact that you've ruled out cycles means that every pipeline must have a final stage.
Right.
And that means that you don't need to sort of require there to be a final stage because that's implicitly defined as part of your representation. You've made it in a legal state unrepresentable.
That's true.
Yeah. Now, the other thing that's important is that you want to make sure that all of the stages are part of the same pipeline, right?
Right.
And also that no stage points to a different pipeline.
Correct. Yes.
We can actually boil these down into a single predicate. And I don't want to be in teacher mode, so I'm not going to try to guide you to it. I'm just going to sort of like tell you what I'm thinking here. Otherwise, I'd be sort of like, what if you try this? What if you try this? And so like cause you to, in a rage, kill me and then find the right solution. Here's what we'll do instead. Essentially, what you want to say is that for every pipeline, there exists a single stage. That is the initial stage, such that the transitive closure of that initial stage is every element of the pipeline, right?
Say that again.
So for every pipeline,
Yeah.
there exists an initial stage such that there exists an initial stage. So it'd be some I initial stage.
Some.
Yeah. Such that the you're going to actually probably use the star. Yeah, let's actually just use it so that the transitive closure of that basically that next stage dot pipeline. Yeah, that next stage.
Pope line.
Yeah, is equal to P.
Like this.
Yeah.
That makes sense. So there's some initial stage, and all of its next stages also have this as its pipeline.
Yes.
That makes sense.
Now, notice that this isn't exactly correct. Do you see the issue here? There's a very small issue.
For every pipeline, there's some initial stage for which all of the next stages are in this pipeline. Some meaning one or more, and there should actually be exactly one.
Right, but yeah, that is true, but that does create a situation where you can have two. Although that is actually ruled out by the fact that if there are two, then they won't have each other in their transitive closures. Actually, let's see. We'd have to sort of get rid of some other things. So I'll just tell you this so you don't have to sort of go through like lots of diagrams. You also have to make sure that I is also in the in the pipeline.
Oh, like I could be not in the pipeline where all of these.
Well, all the stages is part of R.
Oh, I see what you're saying. So I is no longer in the pipeline, but all of its next stages are.
Yeah. Now you can fix this by just using star instead of caret because star
Includes itself.
with the identity. So yeah, if you just place that with star, it'll include I. Is
Wow.
I dot star next stage is the same thing as I dot caret next stage plus I.
Sweet.
Yeah.
All right.
Now notice that once you have this, this plus the fact that you don't have any cycles means that a lot of the problems that you have basically like a lot of the things that you need go away. You don't need converging pipelines because
this.
a converging pipeline would violate the name later predicate. You don't need, you probably need the initial stages because it could be that the initial stage could be a different. So you still would need that the initial stages don't have precursors because it could have
this.
Yeah. You shouldn't need that either because if there exists two separate initial stages that are part of the pipeline, then actually no, that's an actually interesting point because I just realized that there is a mistake here. You're right. I realize that this is not an accurate transmission because the name later predicate now rules out pipelines without any stages at all.
Oh, I see what you're saying.
So what you need to instead say that if there exists any stages in the pipeline, then that part is true. Do you remember how to say that? Or you can just have one stage list per yeah.
Is there a way to say like if there is this initial stage, then all
What
this
is
is,
the most annoying operator in propositional logic that we covered?
oh, implication.
Yes, implication.
So if there is some initial stage that implies that,
Well, not quite. The initial stage is we're basically saying there exists an initial stage with those properties. What we need to then say is that if the pipeline has any stages, then this has to hold true.
right, if
Yeah.
the pipeline has any stages, then all of it needs to be true.
Yeah.
So,
There's
P,
actually two ways we can frame this, one using implication, one using an or.
let's try implication.
Okay. So we
So this
want to say that if
is
there are
going to
any
be
stages, then there must exist an initial stage such that that operation is true.
some P dot stages, jizz, implies.
Exactly.
You
Yeah,
can
that
even
does
do
it.
this, right? Implies.
Yep.
Cool. Is this how you would format this?
I might sort of add a tab somewhere, but
Like that?
yeah. But the format doesn't matter here. What matters is the fundamental logic that we're working with. You can put everything on the same line, and I'm fine with that. The thing I care about in sort of like in helping you here is sort of getting you to think about what the properties should look like.
Hmm.
Also need a colon after I between I and initial stage.
Yeah, I do. You're right.
Now, as a test, can we say this using out imply? How would we say this using or?
How would we say this using or?
Yeah, we'd have a
That
slightly
would
different
be,
thing. Yeah,
so this would be no P dot stages or, or, or.
exactly. I mean, actually, both of those work. Alloy has a fairly permissive syntax, but yeah, both of those work fine. And then once you
Yeah,
have
so this
that,
would work, but I thought it would be confusing to have that and then
yeah,
that.
that's fair. Yeah, just go with or. Plus, it's highlighted nicely.
Beautiful.
But yeah,
Okay.
now notice that once we have this, the basically the reason I brought that up is because the fact one stage list per pipeline allows there to be 0 stage lists per pipeline, and I realized that wasn't covered in our old predicate.
Mm.
But now that we have this, we don't need that fact anymore because the main reason we had that fact was to avoid having a reverse tree, and we can't have that based on that predicate we created.
Right. Yeah, you're
Yeah.
right. Nice. So we don't need this then anymore.
Yes. Um,
Great.
I don't think you actually need initial stages don't have precursors. I want to leave that in out of safety. What I would probably do in this case, and we're not going to do that right now because it would require some formatting, is I would switch that to a predicate and then write a test seeing that is that predicate redundant, and we can actually test that using Alloy by basically creating a assertion saying that with this predicate true, it implies this other predicate is true.
Oh, I see what you're saying.
Yeah.
Okay.
It would basically say stages in the same pipeline implies initial stages don't have precursors, and then I'd make that a test.
I see. So how would we go about doing assert?
So we'd have to change the initial stages on precursors into a predicate.
That's right. So this has to be a predicate too.
So that way we can turn it on and off at will.
And then we would say assert.
Yeah. Actually, write check, not assert.
Check.
I'm not going to go into the details of why I have to write check instead of assert. Please don't ask me. I will not tell you. It's legacy. It's legacy. It's all legacy.
Oh man, you're just challenging somebody to ask you. Check stages in same pipeline
Implies,
implies
yeah.
initial stages that have precursors.
Yeah, and now you'll have to from the I believe the execute menu run that check. We didn't give it a name, so it's going to look execute runs the most recent one. So we actually have to go into the menu, the Mac menu.
Oh, I see what you're saying. Hold on. I'm going to make this a little so that everybody can kind of see it.
Yeah.
And then, although can we do, I mean, we could also name it and just say,
Yeah.
right now it's our only check. So,
Yeah.
all right. So we go into
Execute.
execute.
And then check our only check. Oh, a counterexample's found. That's interesting. I didn't expect there to be one.
That's
What did it find?
it says. We're looking at a pipeline here.
Oh, fascinating. Fascinating. How come the intermediate stage points at the initial stage?
Oh yeah, how about that? Wrong. But the initial stage, oh, we took it.
Oh, I see the issue. I see the issue.
You do?
Yeah.
Oh man, enlighten me. What do you see?
Can we go back to our predicate?
Yeah. This one?
So yeah, you're saying that right now the set of all stages, the pipelines of all the next stages is equivalent to P, right?
Yes.
But that doesn't mean that everything that the set of all pipeline stages, that the set of all that the stage list is equal to that. Basically, what we're now saying is that a subset of let me try to find a better way to explain this. Also, Paul, the question you have, that's basically what we've worked on now. The successor stages in the same pipeline, this predicate should enforce that. But what we haven't enforced is that every single stage in the pipeline is equivalent to, is part of that chain, right? We've only said that everything in that chain is equal to, is the set of, in the pipeline. So what we actually want to do is I dot star next stage equals P dot stages.
I dot star next stage. Oh, I see what you're saying, because then that will be the totality of the stages.
Yes. Now let's try rerunning it.
All right, let's see if it works this time.
No counterexample
No
found.
counterexample found.
Now notice how that core contains 11 top-level formulas. Have you ever clicked that?
No.
So this is a Mac only feature. This shows you the predicates that all interact to make this impossible.
It's all of them.
Yeah, you have it at a very low grain. Well, not the last. The final stages have all the right formulas isn't necessary, as you can see. It's not highlighted.
No, it's not necessary for this particular check.
Yes. Yes.
Wow.
You
Yeah,
can
I
also
got
change.
this by doing. I put a different sat solver on somewhere in here.
It has to. Yeah, you have to use Minisat. That's the only one that's currently programmed in. But you can change the granularity to give you more detail.
Yeah, this is the one
Yeah.
I'm using.
Yeah, Minisat. You can't do this on Windows because Minisat doesn't run on Windows. Which sucks.
God.
But you can also see how you see there's an option for unsat core granularity.
Yeah.
If you change that to scroll down, it's 3 options below. If you change that to like lower, yeah. And then I believe you can also have to change the minimization. If you change both those, it'll actually give you more detail of what specific things lead to it as opposed to just the entire functions. So yeah.
So which of these do you think I should pick?
Actually, you can go to unsat core minimization. Let's start with just changing one thing. Change that to slow.
Slow.
Yeah, now try rerunning the execute. Yeah, now it found only 6 formulas that matter.
Wow. Okay.
Yeah.
So this one, and then of course no stage cycles.
Yeah.
Nice. What does red versus pink mean?
I think it's how important it is. It's not this. The colors aren't well documented.
Ah.
I think it's actually like the levels of decree. Maybe I don't remember off the top of my head. I'm not going to make any guesses.
Okay. Cool.
But
all right.
Yeah.
So let me shut this as soon as I figure out how to shut this.
Mm-hmm.
Oh no, I'm back.
I think if you type anything, it'll decolor it.
Goodbye. All right. Sweet.
And that is, yep. Now, I don't think we even need the fact pipeline has only one beginning and one end. I think we don't need that one either.
The one.
Yeah.
There we go. This one.
Yes.
Because of this.
Yeah.
So we can do pipeline
Mm-hmm.
has, where is it? And if this ends up being true, where'd it go? There it is. All right.
Oh yeah, because you have to make that a predicate too.
Oh yeah, you're right. So
and you're seeing why we don't like facts very much.
Yeah, I'm starting to get it. All
Let's
right.
also raise the scope because normally by scope, it only does about 3 of each signature. Let's change it to like say 5. So we can look at more complicated models
Ah, I
in the
see what you're
check.
saying. So that'd be for 5.
Yeah.
Okay. A
Oh, interesting.
counterexample.
Counterexample found.
Okay.
Because you said each pipeline requires exactly one. Each pipeline requires exactly. Basically, that fact says that each pipeline requires exactly one initial and one final. And our new model allows it to be 0.
But there, I don't even see a pipeline on
Yeah,
here.
no, there's no pipe. Wait, actually, that's a good point. Can I look at those facts again?
Yeah.
Oh, no, sorry. No, there is a pipeline. Because we're projecting over the pipelines. Let's actually remove that.
Okay.
Go back to the theme and then just turn off projecting over pipeline.
Theme. Pipeline.
It's in that bar next to magic layout.
Ah.
Yeah. Sorry, I forgot that projecting over pipeline hides the pipeline like signature itself. Yeah, so basically this pipeline is empty. And while one of your facts, one of the facts we got rid of allowed there to be empty pipelines, the other fact you had requires every pipeline to have an initial and a final.
Right, and we want it to be possible for it to have neither of those, but if it has those, then certain requirements do
Yeah.
apply.
And this, as a consequence, it means that this requirement's now violated. That fact you thought was on what you wanted, it turns out it wasn't because it was too restrictive.
Gotcha. Okay, so let's see. How should we do this?
I mean, we can modify the fact to say like,
So if we were doing stages in same pipeline. But I thought that this would cover it. Either no.
Sorry, what I'm saying is that does cover it. But the thing is that let's go back to the pipeline has one beginning, one end predicate.
Okay. Pipeline has one beginning and one end. Yeah.
This one explicitly rules out empty pipelines.
Right.
It says there cannot be empty pipelines.
Because there has to be exactly one initial or one final stage. So this should actually be this.
Well, that one actually now allows there to be pipelines that have no initial stage but a final stage. Try the following. Maybe just say one initial stage and final stage. I'd probably do the following. I'd say one initial stage and one final stage, or the pipeline's empty.
Oh, I see what you're saying.
Yeah.
No p dot stages or.
Yeah, and then you'd have to here, let's actually do the following. Put that outside the braces and then add a pipe.
Put this outside.
Yeah, so put it after the basically now make it a make all pipeline a use a pipe as opposed to braces. Leave that brace in. Yeah. And between the pipe and the brace, put that no pipeline or. Yeah, there we go. So either there's no stages or that's true. Both of those are true.
Oh, I see what you're saying.
Yeah.
Okay. Oh boy. This, that, this.
Yep.
All right, let's try again.
Still a
counter example. Whoa.
Well, this looks a bit more interesting.
It does. So what's happening? We have an intermediary stage pointing to an initial stage.
Yeah.
An initial stage pointing to an intermediary stage pointing to an initial stage.
I thought we had that rule that said that nothing can point to an initial stage.
I thought we did too. What do we do with that? Yeah, we do. Why isn't that working?
Oh, because it's a predicate, not a fact. So it wasn't active.
Oh. So should I make it a fact again?
Let's make it a fact.
Or should I say, and initial stages don't have precursors?
Yeah. Honestly, what I'd probably do is I'd write a third. Like, let's not do this just yet. Let's just first rerun and see if it is valid. There we go. I'd probably make another predicate called well-formed. That was both initial stages don't have precursors and stages in same pipeline. Oh, actually, pause. I thought stages in the same pipeline proved that initial stages don't have precursors. I thought we already said that should be the case.
Oh, you're right, because we started with this without this.
Yeah. Can you get, maybe it was because of the 4-5. What happens if we remove that?
Okay.
No, not remove the 4-5. Let's try this following. Let's keep the 4-5 and have the stages in the same pipeline implies initial stages don't have precursors, and see if that finds a counterexample. Maybe it just didn't find a counterexample because our scope was too small.
Maybe you're right.
Oh, you'd have to change it. Change it to implies. It's still and.
Oh. Implies.
Yeah.
Wait, false alarm, everybody. False alarm. Like this.
Yeah. Okay. Yeah. So the issue was that just it couldn't find a large. We had the scope too small.
We were thinking too small.
Right. And this is having the same issue where there is. So yeah, it turns out that we're going to need to enforce that nothing can point at an initial stage as a separate thing.
So it's going to have to be this.
Well, that's going to counterexample because it's going to find one where neither of those is true.
And find out what?
That one's not going to work because it's going to find out that it can find a case where neither of those is true.
Right.
Because it could just give you an empty.
Right.
But essentially what you're saying is that those two together make what's called we'll say that makes a well-formed pipeline with those two properties. And those two properties can be, we move that into a predicate, a well-formed predicate that asserts both of those are true.
Like so.
Yeah, and then we can check that well-formed implies something else.
So like so.
Yeah, like well-formed implies, what was the one that we had?
Implies, I think I might still have it on my clip. Or
no.
Well, which one was it? Well-formed implies one of the others. I think pipeline has one beginning and one end.
Yeah.
Beginning, I should just copy and paste it. I'm too far along now.
Sunk cost.
Man.
And let's make it for 4, just to be on the safe side. Like
Okay.
for 5.
Yeah, because with the 3 default, it didn't find anything.
Yeah, because it has to have at least one intermediate, one final, one initial. Right. So now we can know that well-formed implies that each pipeline has one beginning and one end.
That's exciting. So theoretically, that means we could get rid of pipeline as one beginning and one end.
Yeah.
You think we should?
Yeah, let's just toss it.
Goodbye. I like that this is getting shorter.
Yeah. And let's do the same thing for next stage, always in same pipeline. Let's turn that into a predicate and test if well-formed gives us that.
Good idea. P-R-E-D. I can spell pred. Wait, I'm not going to do it this time. I'm going to do what I should have done last time. I'm going to copy this. And I'm going to paste it. Like so.
Yeah.
This is... All right. Ta-da!
Yeah. Now, here's the thing I'm going to point out is very interesting about this. Do we necessarily, it might be easier for us to implement initial stages for us to implement next stage always in the same pipeline in the code than to implement well-formed, in which case we might want to flip it around and say that we want to find things that are easy to implement that enforce well-formed.
I see what you're saying. Interesting.
But it's just a material about like what it means to model and specify things. It's not necessarily a statement of what we should be doing right now.
Right. Yeah. Sort of a case of like defining the corners so that the rest of the room takes care of itself.
Yeah.
Yeah. Yeah, that makes sense. All right. So, do you think there are any more of these that we don't need?
I'm not sure.
Okay, but I'll do
No
it.
stage cycles. We'll need no. I think we'll need no stage cycles. Let's actually test that we need no stage cycles by
Okay,
turning it into a predicate and checking that we get a failure.
spread, no stage cycles. And we're going to do it here. No stage cycles.
Yeah.
Here we go.
There.
Counterexample.
Yeah. That's what we should expect because we allow for cycles. So what happens is that we no longer initial stage is still defining the entire space, but we just have a lasso as the term goes.
Right here.
Yeah.
Yeah. This double-headed arrow is cute, though.
Mm-hmm.
That it has. All right, so we need no stage cycles. That makes sense.
Yeah.
How would we do... Okay, never mind. This makes sense. All right. Cool. So then we do need this one
Mm-hmm.
and that one. And then we get down into the formats.
Yeah.
Although I also have this I think I can get rid of this. We're not using
Let's test it. Oh yeah, no, that's just a command test. We don't need that. That was just for you to be able to like simplify your run commands. How's everybody feeling in the chat, by the way?
What do folks think?
I think we've blown all their minds.
Oh man. Your streams could come with a warning. Please bring espresso. Prepare for launch.
Can we see the signatures again? Yeah, let's do that.
Absolutely. So here's the SIGs. I'm actually going to put this one on one line so that you can see all of it at once. So we have two generations of abstract signatures on stage. We have the abstract signature stage. Let me move format down. Oh, whoa. How did I do that? How do I do that? Stop. I swear I'm trying to make it easier to read. Okay. So we have our stage, and then final stage extends stage, and then an abstract signature that also extends stage, and then these implementations of passing stage. All right, looks like we got a couple questions. Wondering about all the facts and predicates about things not having a next stage that is an initial stage. Yeah, we can take a look at that again. It feels like there are two high-level structures. Set inclusion, that being stages in the pipeline, and linked list stages that could be handled directly. Roll says his mind is split right now.
I think that means he's also like dealing with like some other like necessary task. Not that we like ripped his mind in half and stomped on one half.
Oh no!
I'm assuming it's the more mundane thing, not the less mundane ruining his mind thing.
The ruinous mind thing.
Yeah.
Yeah, so we can take a look at the next stage thing. Looking at all the facts predicates about things not having a next stage. Yeah. So this is where we set.
Oh, I see. Oh. Are you thinking that tilde means not having, or sorry, I interrupted.
Oh, you're good. Because the tilde reverses it.
Yeah. So we're basically saying that there is no stage that points to an initial stage.
You know what we could do?
You know what we can do? Oh.
I mean, what were you thinking we could do?
We can modify depending on how we can structure our system, we can actually modify the signature field to rule this out implicitly.
Really?
Yeah.
Okay, well, I'm most of the way through this function, so hold on.
Oh, yeah.
So we could do this, and then that would be previous stage. Like so.
That's going to give us all the previous stages. That's going to give us just all of the stages for a pipeline, right?
No, because the initial stage shouldn't have any previous stages.
Sorry, because like next stage is no, because P is a pipeline, right? In previous stage. See,
Yeah.
okay, so major gripe. One of the biggest problems with the editor right now, which I think is like the overriding problem, no line numbers.
Yeah. Yeah, that is a problem.
But yeah, so in previous stage, you say that it's next stage is a actually just execute this, see what happens. Yeah, because previous stage is a set of P is a pipeline. So you can't call P dot previous stage because previous stage takes in a pipeline.
Oh yeah, this has to be a stage.
Yeah. But in any case, let's do it. Let's do a more simple way of dealing with this.
Okay, let me
Let's
back
go.
out what I
Yeah.
did. Okay,
Let's go up to our definition of passing stage.
passing stage right there.
Yeah. You see how we have next stage equals one stage?
Yeah,
Change that to next stage equals one stage minus initial stage.
like so.
Yeah. I think this takes away the need to actually even have the predicate in the first place.
Frank says that he gets line numbers.
Oh yeah, because he's using a Visual Studio Code.
Oh man, that's a good idea. So then what? Well, then what's the trade-off? Why wouldn't you use Visual Studio Code?
Because he apparently can't get minisat highlighting.
Oh, I see. See, reading. That's what.
Not formal methods. Formal methods does not involve any reading. But yes, now that we've said that next stage cannot include initial stages, I don't think we need to sort of make sure that we don't need initial stages don't have precursors because that stage cannot point at it.
Is there a way that we can write a check to test that?
Yeah, we can write a check to say that initial stages don't have precursors is always true.
Check. We'll make another one.
Yeah.
Check. Initial stages. Oh, here.
Just copy it.
One of these days I will learn.
That's why I'm a
I wish
Vim
I had
boy.
the highlight. I don't know. I have like key bindings in my other. Oh, I have to wait.
Yeah, you have to select it. Just give it a name.
Stages always first. Initial stage is initial. Seems a little too cheeky.
Yeah.
No.
And let's click on the core reduce. Let's click at the unsat. Let's look at the core, and then scroll up. Yeah, so we can see that that change did have a critical role to play.
Wow. How about that? Okay, so then we don't need this.
Yeah, we don't need that. Which means that we can take it out of well-formed.
Aha. So now we just have stages in same pipeline.
Yeah.
So now, which of these names do you like better? Should we rename stages in same pipeline to well-formed?
I think let's leave well-formed because if you want to add more properties, we can just stuff them into well-formed as opposed to having to like.
Yeah. That's a good idea. All right. Rock on. So, would you pull this check out or would you leave it in there? Do you use checks as like transient? How do you use checks?
I use them as both. I use them as like aids for writing the spec and also as like properties of the system.
I see.
Actually, that might be a good place where assert would be useful, but we're not talking about assert. Assert never happened.
It's like the opposite of Mean Girl. Stop trying to make assert happen. It's never going to happen. All right. So, would you get rid of this one specifically?
Probably.
Okay.
Because
I would too.
yeah.
But I want to keep this one.
Yeah, no, that's important because that's actually a property we want to like enforce as part of like our system.
Gotcha. Okay, that makes sense.
Yep.
All right. Cool.
I'd also personally move the function no state. This is again not important, just my own petty desires. I'd move that closer to like the definition of pipeline.
Yeah, I agree with that. That's where it goes.
Oh, Raul. Okay. So you know how there's predicates and you can run predicates? It used to be that you could only check basically asserts were predicates that could only be checked. So you would run predicates and check asserts. Then about 5 years ago, everybody realized this was stupid and made it so that way you could also now check predicates. And now there's no reason to use asserts ever, but it's in there for legacy reasons so as not to break old specs.
So you don't recommend that people start picking up and using assert?
No, it literally does nothing. It is a very small amount of syntactic sugar in very specific circumstances and will save you a grand total of like 3 keystrokes.
So it's like a vestigial keyword.
Yes.
Oh man, I love that.
Backwards compatibility, yo.
I mean, it's important. It is important.
It's actually really funny because I'm going to talk about some like fun alloy board stuff. Is like we realized there was a bug in like one of the libraries, and like we're going to fix the bug, but it might break backwards compatibility. So there was just a okay, show of hands. Does anyone use this library? And because of course like the alloy community is relatively small, we could just go around and ask every single person, and they're all like, wait, there's a library for that. So you'll just change it and go like, yeah, we can just change it. Nobody's gonna notice.
Oh my gosh, that's, oh man.
Pretty great.
Some of the nice things about something not having scaled quite yet.
Yeah.
Oh man, fantastic. So Paul, earlier you mentioned, where does it say? That there were two high-level structures, like managing the stages in the pipeline and then managing linked lists so they could be handled, and linked list stages that could be handled directly. That being, yeah, I would say that's accurate, with the caveat being that there's only one of these. There's one of these linked lists in every pipeline. Or zero. Zero or one. Yeah. And then if there is at least one, then that one has to subscribe to all of these rules. But yeah, they could effectively be managed separately of one another. I think. Hillel, what do you think?
I don't think I'm right now working at a medical capacity where I can really think that through. Basically, if I understand this correctly, we have this idea that pipelines have accounts and pipelines, and we're trying to keep those in sync. Essentially, so what you're basically saying is, can you just define one in terms of the other to say that the set of all things connected to by the initial is the set of the pipeline? Is that the case? I think you could probably do that. I'd worry about like us getting away from how the system is designed and how we're implementing it. Yeah, that's my immediate thought. I wouldn't want to touch it just yet. I wouldn't want to dry that up just yet.
Gotcha. We got a question about assert versus.
Actually, that's a good question. Are pipelines is in the database essentially where you're storing pipelines? Does it store these stages?
Does it store the stages in the database? Yeah, it does.
Yeah, that's.
So we have the stages, and each stage, the way it's implemented is we have the stages, and each stage has a number. And so within a pipeline, you can only have one stage of any given number. And so it knows what its number is, and then it knows what the next number would be, and it puts all its outputs in a folder named with the next number so that the next stage knows where to get its inputs.
Are the numbers always sequential?
Yes. But it's not enforced. It's just like a researcher could not do that and the app would break.
Okay. Yeah, that's probably something you should document. But yeah, because that's how the system is actually implemented, simplifying that in the model would potentially cause us to like lose touch with the system as it exists. So I'd avoid making that change just yet. Of course, that makes our job of specifying harder, but of course, that's why we're specifying, not just blindly coding.
Right, and we could use it, I would imagine, for exploratory reasons to figure out if we made this change in the long run, what limitations would we run into? What conditionals do we need to add? Like, is it going to make our code simpler, or are there going to be more things to deal with?
Yeah.
Than there would be for just, like, adding checks for the researchers that, like, these numbers need to be sequential.
Yeah.
So, that's my thinking. Rock on. What do you think of the formats code? Is there ways to simplify that, or did I do that? I'm interested in your thoughts on that because I was very proud of this code,
Mhm.
but if it could be better,
Um, I think it could be better, but I also think, and this is pretty critical, I think the amount of better that we can make this is dramatically less than we can make. Like, do we can make better? Like, I guess here's one thing you could say is that initial stage at input format equals JSON, right? You don't need to go all I initial stage. You can just say initial stage at input format equals JSON, and initial stage at output format equals TIFF.
oh, I see what you're saying. So
Yeah,
this goes away,
yeah,
and then this happens.
yeah. And then because you're in braces, you don't even need that and. You can just write initial stage dot. Yeah,
Wow. How the heck? How did that happen? Initial stage at output format, and then I
yeah,
don't have this.
yep,
Rock on. Yeah, this was the part that I did after I had honestly this part up here. It was like a lot of tooth and nail.
yeah.
It took a lot. And then by the time I got down here, I was like a little more warmed up, I think,
Mm-hmm.
which helped.
There is an extremely stupid thing you can do that I'm not going to recommend.
But what is it?
Let me think about how to put this right. You'd have to use something I did not cover in the workshop because it's more of an advanced feature, but you could sort of do
Well,
this
let's
weird thing.
do it.
No, let's not.
But this is, we should do it.
No.
Okay.
It would make things,
Okay.
let me put it this way, it would make things less understandable.
Oh, okay. Maybe let's not do it.
Yeah. So all stages should have the right formats. That one should be, I'll show it to you after the work. I'll show you two afterwards. If you want, I can just tweet it to you, like the silly thing, but it doesn't really matter here. And that can do the same thing. We say that final stage dot output format equals JSON.
Yeah. Is this the kind of thing that you would typically put in facts or predicates?
It depends. Is it something that you can enforce like as a database constraint?
Yeah.
Probably a fact then.
Okie dokie. That's a good thing for me to keep in mind. Whereas predicates, would you say that that often shows up in the implementation as conditionals?
Yeah, or like as things that you have to, as basically things that you are trying to build in.
Gotcha.
And I mean, of course, it's things like I've seen people try to implement facts. I've seen people basically have premise. Think of it more. The important thing is more of like, do you want this to always be true? Or do you want to be able to toggle it on and off per like property?
Right. Yeah, that makes sense.
Also, remember you can use quotes. You don't have to. You can use strings for fact names. You don't need to use You don't need to use like underscores.
Oh, right. So I could put quotes around this, and then I wouldn't have to put the underscores
Yeah.
at all. What's your preference on that?
I strongly prefer quotes because then I can just use regular English, and it doesn't look as like out of place. So I can say like final stages all are JSON, all output to JSON.
Ah, yeah, that makes sense. I like that better too.
Yeah. And then final stages have matching formats.
This one.
Yeah, that one's interesting.
Why?
I think you can probably
Interesting in like a disaster way, or interesting in like
it
a
may like it would be tricky to sort of make simpler. Although actually no, you've got passing stage. Does passing stage include initial stage?
no.
Oh,
Does it? Wait, hold on. I'm actually hold on. Let me look. Passing stage does include initial stage. You're right.
okay.
Final stage is the only one that's not passing because it doesn't
So
send.
you can say passing stage as opposed to initial stage plus intermediary stage.
Oh, I see
Yeah.
what you're saying. So this would be passing stage
Yeah.
for all passing. Yeah,
Yep.
that makes sense. For anybody that has to pass data, there's restrictions on what the format is.
Yeah, and honestly, I would probably make that a predicate almost because I imagine that's going to be harder to enforce.
Yeah, it is. That's not something that you can enforce in the database.
Yeah.
That we do in code. Yeah, that makes sense. And then how would you ensure that that gets included in the run?
I'd probably throw that into honestly, I'd throw that into well-formed personally.
All stage. Yeah, actually that makes sense, doesn't it? And,
Yeah.
well, no, we're in brackets, so we don't need that.
Yep.
All. Wait, I have another question then. So
Yep.
suppose that we were to do this like that.
That does not work, unfortunately.
Okay, that doesn't work.
We are exploiting for the fact string. We are exploiting a specific undefined behavior of the compiler that I am fighting to make defined behavior.
But then what are you going to do about predicates? Because you can't do it for predicates because you got to be able to call the predicates.
Yeah, no, that's what I'm saying. Like that's why it doesn't work for predicates. It only works for facts because of that undefined behavior.
Ugh, but then it's inconsistent. Oh, man.
I know it's actually very consistent because you never ever use the name of a fact. Well,
Yeah, I guess
so
that's
that's why you can
true.
use strings.
That's true. Whereas with the predicates, you do have to call them in other
Yeah.
places. Yeah, that makes sense. That makes sense. So this is the way well-formed would now look.
Yeah.
And then if we execute it,
You can now also find well-formed.
what do you mean find well-formed?
You can do run well-formed for like 5 to get examples of well-formed pipelines.
That seems like cheating. Run. So this would be run, whoa, run.
You don't even need braces at this point. You can just put well-formed like that. Yeah.
Like that.
Yeah.
And then I can go to execute.
And now you can see if like the well-formed ones look weird. Like that one looks really, no, that one looks fine.
It does look odd because it has these two things pointing to pipeline, but
yeah.
it's probably going to give us 80 of this particular variety.
Yeah, so you'd probably want to do something like well-formed and something else to like give us something nicer.
Run, well-formed, and, oh, right, they're both the same window, so I have to do, let's do this. Pred. This will be a good example of when you would want to turn something on and off, maybe.
Yeah.
So, relatively involved. And this one is going to be, there's some pipeline for which the number of stages is greater than 3.
Yeah.
Run well-formed. So now I need the braces.
Yeah.
Because I want to include more than 1.
Yeah.
And do I need an and? No, I shouldn't.
Braces.
Relatively involved. Okay.
Oh, that ran 1. Oh yeah, that it ran it did the right thing. Never mind.
Because it happened to run the most recent thing, which happened to be that.
And there we go. And now let's go back to using projection. Let's see, it's going JSON to JSON, JSON to TIFF.
Project? Should I do pipeline?
Yeah, let's just make that nice. There we go. Beautiful. Okay, so JSON TIFF, TIFF JSON, JSON JSON. JSON TIFF. TIFF JSON.
So it just goes back and forth and back and forth.
Yeah, maybe it's making transformations to JSON.
Yeah, maybe. JSON, JSON, in JSON, out TIFF, and then TIFF back to JSON. Okay. What would be awesome? Well, no, that's just me. I don't think that would actually be that useful.
What would be awesome?
Well, I think it would be useful if you could somehow, with the like at the beginning and end of the relationships, code the input and output formats that way, so you could make sure they matched.
Oh,
like
in like the visualization
for TIFF and a red dot for, I don't know.
Oh yeah, go to evaluator. Let's see if we can do that.
Oh man, that would be
Oh, sorry, not evaluator. My mistake.
Theme.
Yeah. So what are you trying to do? We're trying to make them match based on the type?
Yeah, I want the two sides of the relationship to demonstrate the input format for where the point of the arrow is and the output format where the base of the arrow is. So we can make sure they match.
Yeah, it's going to be tough.
Yeah.
What happens if you click on input format?
Input format.
Yeah, does that give us anything interesting? No, it does not. What about if we click on sig format? That's just going to change this. Yeah, no, I don't think there's an easy way to do that. I'm sorry.
It's okay. Thanks for thinking about it.
Item connected.
One of these days. I mean, that's not really what this diagram is for 100%. So I already think that including these as attributes has made it easier to read than having it like point to stuff.
Yeah.
I didn't even know the enum thing. Like I wasn't thinking about it in those terms, but now that you mention it, that's exactly what this is.
Yep.
Yeah. I don't know.
Let's actually have one more bit of fun. Let's make sure that the let's say that input format should include that all the input formats used should include like TIFF and CSV. So like say as part of relatively involved. We can put this as part of relatively involved.
Yeah, I like that idea.
Let's just say that like because we have the set of if we do like what is it pipeline basically what is it stage dot input format is it? How do you get the set of all input formats? Oh, yeah.
So input format is like a relate.
Yes, so we can do input stage dot input format.
Hold on, let me find
Yeah.
relatively involved again. Some all.
I wouldn't use knowledge. I just say, for example, like CSV plus JPEG. Equals CSV.
And then like this.
Well, yeah, no, because that would require it to be both of them, which doesn't work. I was thinking something more like.
How would we say we want to make sure all of these things are in there somewhere? We can't do that maybe, but we could do this.
I'm putting it in the chat.
The chat.
Yeah, although I think it would you might have to go to all chat as opposed to just top chat. I put it in the
all chat. Oh no, yeah, I have to do all chat. Well, it says okay.
Apparently I am spam. CSV plus JSON in stage.input.
Why does it think that you're spam?
Fuck if I know.
You're not spam, don't worry.
Jewish. It's not even kosher.
Oh man. CSV plus JSON in stage.input format.
Yeah.
Like this.
Yeah, let's see if that works.
That makes perfect sense. Yeah, absolutely. Yes.
And we can't do equals because we also want to make sure that like other things are allowed too.
Yeah, all stage.input format contains both CSV and JSON. Yeah. PNGs, JSONs, CSVs, PNGs, TIFFs, CSVs.
Out
yeah.
TIFF, out CSV, in CSV, out PNG. Nice.
Yeah, and then it's doing something to the PNG. This is actually quite accurate to something that we would actually see. Because you get your TIFF file down, you get your JSON, you get your TIFF file out of that. You pull out CSV data, which is a way for you to organize all of the wavelength radiation information. Then you use that to construct an image, right? So you construct this big image, but it's really big. And you want to slice it up into a bunch of smaller images so you can see in more detail. That would have an input type and an output type of PNG. Then you would use that to upload to the service all your images. This is basically exactly like what you would see for a floating forest pipeline.
Hooray!
What? This is awesome. Oh my gosh. Well, I feel like, I wouldn't say I feel confident with this stuff, but I feel like I learned a lot of things. Here, let's change this to initial stages all have the proper formats. I think that's our last fact. I think we managed to defact this thing.
There's now 2 facts.
2 facts.
Oh, and actually there's one implicit fact that this not in next stage. We don't need that either.
This?
So it's online. It's the implicit fact above sig initial stage intermediary stage. You see how this not in next stage?
This one we don't need anymore.
Yeah, we don't need that.
Well, that's nice.
Yep.
So an implicit fact, y'all may know this, but an implicit fact, right after you define a signature right there, you can make implicit facts in a second set of curly braces right here that the system will always assume things in this to be true. Is that accurate, you think?
Yeah, and I strongly recommend not using them.
Okay. Don't do what I did, kids.
In order to use that properly, you have to introduce syntax that not even like the creator of Alloy remembers. That I had to introduce him to. He was like, yes, this is how the syntax works. And he's like, wait, really? I wrote that? And I'm like, yes. And that's why none of us use this.
Oh my gosh. You know, I think in programming, the more you hate a pattern, the more likely it is that it was in fact you 6 months ago that put it in place.
Yep.
The minute you're cussing about a bug, the probability is indistinguishable from 100% that you are
You
some.
will you will have noticed that in my workshop, I never once introduced the @ operator.
No, what is that?
I'm not telling you
Why?
because
Bring
it's
it
that
up and
I
not
remember
say
how I
it?
said that there was a part of the syntax that the inventor of Ali completely forgot was part of it.
I
It's the
guess.
syntax.
What does it mean at a high level?
It's the deshadowing operator, which lets you deshadow shadowed variables.
Ah,
But you should never ever get yourself in a situation where you have to worry about shadowed variables, because if you do, something's gone horrifically wrong, and that's why nobody uses the @ operator
ah.
except me, because I have to sometimes answer Stack Overflow questions of like, what is this doing?
Oh my gosh. So you deliberately engineer a situation where you need it.
Yeah,
I love it. Oh man.
and it saves you a grand total of like 5 keystrokes.
Speaking of very few keystrokes, I have a stylistic question about signatures. If you have an empty signature to
Yeah,
use,
that's
can you
fine.
present it this way?
Yeah, that's fine.
Okay. Because I had done that here.
Yep.
Mostly, I secretly just wanted to get all of the signature stuff onto one screen like this, which I finally succeeded at.
Yep.
In no small part due to taking away that implicit fact, so that was good for my extreme vanity reasons.
Yep.
This is amazing. Would you ship this?
How much are you paying me?
I mean, and what's the deadline?
Yeah. I think this is probably a good place to sort of like stop on our project. Oh, putting the commas. Oh yeah, Frank, what's the justification? So you have to put commas after, like between field definitions, but you can put as many commas as you want. So I like to put commas before to act like little bullet points. That way you can reorder them easily. If you wanted to say move output format above input format, or if you needed to delete something or add something new, you wouldn't have to mess with the commas.
Rock on. What
So you
other
can actually
questions?
do pipeline comma input format.
You could do this. Wait, that?
Yes,
Okay.
totally fine.
I wouldn't.
Don't.
That's just me. I would not. Oh, but you could do that with commas at the end too, like cell.
Yeah.
Question. So why not do it at the end? Why do it at the beginning?
That's just my personal preference.
Are you permitted to have, so you can have commas at the end of the final one too, and it's fine.
That's
Rock on. So there you have it. Yeah, I just put them at the beginning because you put them at the beginning, and you explained kind of why, but I just figured, all right, this is how I'll do it.
honestly, I think putting commas at the end looks uglier if you have like, I feel like it's easier to have a preceding comma looks less like ugly than a dangling comma, personally. And I'm part of the school where you define like if you have like a lot of like methods, you'd go like foo.bar then on new line dot baz as opposed to foo.bar dot on the new line baz dot. I don't like that.
Mhm.
Again, my preference.
That makes sense. Sweet. I use the after comma because C# style guides do that for multi-element lists, so it's what I see all day long. Makes sense.
We're giving you flexibility. You can choose.
Frank, do you find yourself using Alloy a lot at work? Hmm. Sweet. Okay. All right. Static stuff's fine. It's the dynamic modeling.
Oh yeah, dynamic modeling is a lot harder than alloy. That's usually like the more you like, you can do some dynamic modeling, but like it tends to not be the right tool. We are adding to the next version of Alloy Electrum syntax, which will make it easier to do dynamic modeling by adding in like proper like prime and like action operations. So that's coming, I believe, in like early November is the first beta. I'm dreading it because then I'm going to have to update all the reference documentation. Speaking of which, in case you aren't familiar with it, oh, let's read the docs.io. It works either way. I put in the comments, I put in a link to the reference documentation we're working on to make it easier to use this without having to buy the book. I believe it even includes discussion about shadowing and says don't use this.
Hillel, is the action syntax the kind of thing that would change your recommendation on when folks should use Alloy versus TLA
I
plus?
don't know. I'd have to use it a bunch in Alloy to know whether or not, like, how much it changes the equation. I don't think it'll be a perfect change because there's like a lot of stuff you can't do, and like there's a lot of stuff that TLA plus will remain much better at, but it might cover one of the fundamental differences. We'll see. I expect it'll be helpful for a lot of people, but not change when, but not like be a dramatic like. I don't think it'll have a dramatic impact, but I think it'll have a nice impact.
Awesome.
That's just my personal opinion. I have not used it yet, so I don't know. I've been sort of avoiding touching it until like it starts to crystallize, so like I don't like end up instinctively writing a bunch of documentation for something that changes.
Right. Yeah, that makes sense. Is it like under development right now?
Yeah. I mean, I think that the syntax is mostly set. They're just like working on integrating it.
Makes sense. Cool. All right. Folks have any final questions, thoughts, concerns? It seems like the chat is like relatively well versed in Alloy. Everybody kind of knew what it was, which they had like heard of it at least.
I have the best followers.
Which is, I don't know, I was a little bit surprised because Alloy is not something that I had until I started following you on Twitter. I had no idea it even like existed. Which is funny to me because I have worked in environments my entire career that were extremely rigorous about testing software. However, testing was rather narrowly defined in as much as testing typically meant automated tests and typically meant specifically automated unit tests. So it's been interesting to kind of branch out and try to learn more about all of the different methods of software verification we have and where you would use them. And most importantly, or at least from my perspective, what was important was that I found myself running into the limitations of automated unit tests insofar as that all my tests passed and the app still breaks. And like, rather than accepting that as a given, I was interested in finding out how do we prevent this kind of thing? How can we check for this better than this? And then doing that Raft implementation, I got, I guess, more hands-on experience with like what happens when you try to implement a system that was designed specifically to be unambiguous in its design.
Yeah.
And, it it made a bigger difference in the implementation than I thought it would, which made learning something like this even more appealing than it already was.
Yeah. I think it's interesting because definitely these tools are extremely obscure. Like it's weird because like I've gotten so deep into this bubble that like I'm like, yeah, like I will tell people like, yeah. So I think like there's some really interesting trade-offs of using new SMV here versus like using a proper like event beep model. And people are just like, what the fuck, Hillel? But these are powerful tools, and I think there are like reasons why they aren't as popular as they could be. But I think like we're making really rapid progress in changing that. And I think that once we like, as we start to like improve the usability and like education on these tools, we're going to see a lot more people using them and a lot more people seriously benefiting from them.
Yeah. Well, I'll do my best to carry the torch. This has been a really effective way for me to think about how I would go about designing like a system like this for sure.
Mhm. Yeah. Normally here's where I plug my stuff, but I'm pretty sure you all know who I am. So
Fair enough. All right. I don't know. How do you typically land these types of things?
I got a website, hillelwayne.com. I got a newsletter, buttondown.com/hillelwayne. I got a Twitter. I got an Instagram that has nothing to do with tech. I'm very clearly not teching Instagram. Um, be good to one another.
That's how you find him. I guess I'm kind of the same. So I'm Hey Chelsea Troy on Twitter. I'm chelseatroy.com on the internet. I do a lot of writing. This, so there's an introductory stream that goes into some of what you saw today. When we started, it shows kind of how I got to that point. And there'll probably be a blog post up for this as well with some show notes on this. That's got my Instagram, my Twitter, and everything. And once my Instagram is also very non-technical. It's like apple picking and pictures of the river and pictures of the gym and all that good stuff. Sweet. All right. Well, I think it's time to call it an afternoon. What do you think?
I think it's evening. I should probably like start working on dinner or like something like that.
Or working on juggling. What happened to that ball? The ball is gone.
I cut my hair. I shaved.
Between now and the beginning of the stream.
I mean, yeah, like I can turn my I can turn my like microphone on mute. It's not
Oh,
that hard.
it happened so fast that we didn't even see it. All right, folks. Everybody have a good afternoon, okay?
Have a good afternoon, everyone.
Bye.
Bye. I think
All
we're still
right.
streaming.
We are. I have to figure out how to stop it. Stop live stream.